Okay, folks, so this is Chet. So we're going to do law of cosines, but we're going to find the side. So if you look at this problem here, here we have our side, angle, side, and then across from it. So you might be tempted to do law of sines. This angle is across from that side. We have the 10 is across from an angle, but we don't know it. And 17 is across from this angle, but we don't know that. So if I set up my proportion using the law of sines, I might have this part right here. X is across from the sine of 38, and side 10 is across from angle B, which I don't know. If you can look at this, we have two unknowns. That's not going to help us. I don't know which to solve for. Okay, well maybe if you took the 10 is across from the unknown sine of B, and side 17 is across from angle C, again, these two are unknown. I don't know what they are, so we can't solve it. All right, well, if I move this to the first and last, let me just stretch this guy out a little bit. Here is X is across from sine of 38. That's unknown. And my 17 is across from some side angle that I don't know. There's two unknowns. So that is why we cannot use law of sines for this problem, because there are just too many unknowns. Let me shrink that up a little bit. So there's two unknowns right there and there. We can't solve it. Okay, so let me scroll down. Let me go to the next page. And I'm just going to give you the formula. Now in our formula, we have our side squared, and I'm going to start with this last one. It kind of looks like the Pythagorean theorem. C squared equals A squared plus B squared, but there's more to it. We have to subtract twice these two sides here times the cosine of the angle that's across from this side C. Well, across from side C would be capital angle C. So that's our law of cosine formula. This formula is the same in every case. If I use this side B, then the other two sides would be A and C. Kind of looks like the Pythagorean theorem, but then there's more to it. Minus twice these two sides times the cosine of the angle that's across from side B, which would be capital B. And then we have our last one here. We have side A. Well, what two sides are missing? That would be B and C. Again, kind of looks like the Pythagorean theorem. Definitely down here, but not up here. Minus twice these two sides, B and C, times the cosine of this angle across from this side, which will be capital A. Okay, so there's the law of cosines. As you can see, they look very similar in every case. All right, well, when we go to our problem, here's that same problem we were working on. Oh, and let me back up a second. Let me get back to here. If I solve this equation for C, what am I going to have to do to both sides? How do you undo a square? Well, we're going to have to take the square root. So C is going to equal all of that. All right. So let's go to our problem. Here's our problem here. And we know if we're solving for side X, we got to take the square root of it. That's exactly what we just did a second ago. So I'm going to put in my two sides, 10 squared plus 17 squared. Again, kind of looks like the Pythagorean theorem. I should put an equals there. Minus twice these two sides, a 10 and 17, cosine of the angle that's across from x, which is what we're trying to find. That angle would be 38 degrees. Now, the real nice part about this is I can punch it all in one step in a calculator. So let me get the calculator up. And what's nice about this problem is whenever we're finding a side, you can punch it all in one step in your calculator. So now that I'm on my arrow, I can get the calculator working. So I have to take the square root of, right here is my 10. I got to square that, plus the 17 squared minus 2 times both sides times 10 times 17. Great. And then we have the cosine of 38. And let me just make sure I'm in degree mode. I am. Now, I need a parenthesis to close off the cosine of 38. But see this? This is the square root of all of this. So you see that parenthesis right there? I need another parenthesis at the end. And amazingly, all I have to do is hit enter, and notice we now have what x equals, 11.003. So therefore, x will equal 11.003. I don't know what units I'm in, but there you go. Whenever we find the side, when we find the side, you can immediately punch it all in one step into the calculator. All right, folks, that's part 1, and I'll be back with part